Okay. So good. All right. So today we'd like to talk about horizontal asymptote and horizontal asymptote. So let's review vertical asymptote. So vertical asymptote has nothing to do with horizontal asymptote, but there is some characteristic. We talk about vertical asymptote. Vertical asymptote is like, let's see what I'm gonna make fun of. It's like vertical asymptote is something that, you know, if you do go in so close but you cannot touch. Does that make sense? So it's gonna have like this or like this at the x value. So you're gonna have like, it's kind of like the zoo. Kind of like Zacharias relationship, right? It's almost there, but you're never gonna get there. It's like the asymptote, right?
I don't get it, but
I get it.
I get it.
You basically said you're never gonna get a girl.
But I
Or
have.
in your opinion.
But it's just not there. It's just.
You're not gonna be
It's
there.
not gonna.
Oh wait,
It's not there.
No, I'm just kidding. Wait, you have a girlfriend?
You had.
Oh, he had. See, that's why.
I broke up with her though, so I'm the real winner.
But.
You want a real winner?
I'm the real winner.
I like the confidence though. I like the confidence. Can you see the whole board?
Yeah, pretty good.
Okay.
Yeah. One YouTube right now. Yeah.
Okay. So basically, vertical asymptotes. Let's review a little bit vertical asymptote. Vertical asymptote is gonna be a when denominator equals 0. And the graph probably looks like this. So you have something like this, either like this, or like this, or it could be like this, going like this. You're never gonna touch that line, so that's something you're not gonna reach, okay? Or something like that could be both going down like this. So that's one of the things about vertical asymptote. So you're gonna get so close to that vertical asymptote, but you're not touching them when denominator equals 0. But however, find the horizontal asymptote, a lot of people think this is, well, let's set numerator equal to 0. That's not right, because actually this is something you have to memorize. When limit as x approach infinity, we're gonna talk about why limit x approach infinity. Limit x approach to infinity of f of x equal to L. L again is a constant, so it could be 5, could be 3, could be -3, could be -5, could be, you know, any numbers. And sometimes it might not exist. Yes, if you got infinity, then you don't have horizontal asymptote. So what happened when limit x approach to negative infinity of f of x equal to L? So you not only have to reach for the positive infinity, a lot of people tend to forget this one, which is reach negative infinity, which makes a huge problem. Now, is this question I'm talking about is always on SAT, always on the AP exam? Yes. Okay, so when they say finding horizontal asymptote, you have to think about limit x approach to infinity, or limit x approach to negative infinity. So you might have 2 horizontal asymptote, but you may not have more than 2 horizontal asymptote. The maximum is 2. Okay, so the maximum is 2. So here, the most you can get is 2, but you can get 1. Okay. So now in this case, that you have a find horizontal asymptote of f of x equal to 3x minus 2 over square root of 2x squared plus 1. So if I have this case, I'm going to go to two situation, which is limit x approach to infinity of this x, 3x minus 2 over square root of 2x squared plus 1. And then you have a limit x approach to negative infinity of 3x minus 2 over square root of 2x squared minus plus 1. Okay, so you're gonna reach 2 possible situations. So you might result 2 different things in this case, but first of all, how do I do this problem? Now, here's a tricky question. What is highest degree on denominator in this case? So David, what do you think?
The highest degree denominator
Yeah.
is x.
Why is x?
Because if you square root it, it's just
Right. So if you think about it on the side, right? Square root of x squared that's technically what? X, right? So in the case, it's X. But if inside a radical, so it's really tricky question. The correct answer should be square root x squared, if it's inside a radical. So therefore, I'm going to divide it by x for the denominator, because we recognize square root x squared is x. So, but if I divide it inside a radical, I need to divide it by x squared instead of x. Okay, so what I'm going to do is I'm going to take a marker here, I'm going to color code this. I'm going to say limits as x approaching infinity, I'm going to say 3x minus 2, and we know it's divided by x, but square root of 2x squared here plus 1, and we're going to say, hey, we're going to take this divided by x, and we're going to take this divided by x, but here we're going to divide it by x squared because it's inside a radical. Does that make sense? So inside a radical, so that means x squared. So that, everything kind of starts to say, okay, well, inside a radical, because this is all part of radical, because we divided by x squared inside a radical. If it's outside, it's going to be x. So now, when you have this, you have limit x approach to infinity of 3 minus 2 over x all over square root of 2 plus 1 over x squared. Now, when I x approach infinity, as long as the denominator is an x, if I reach infinity, that part is going to go 0. So it's going to be 3 over, this part is going to be square root 2 plus 0, so therefore it's 3 over square root 2. So that means I have a horizontal asymptote at 3 over square root 2. This one is a horizontal line. Okay, it's a horizontal line. Does that make sense? Now the only thing different is this case. This case I have 3x, so I'm doing the same thing. Limit x approaching negative infinity, because that's a negative number. Do you understand? So what we're going to do is we're going to reach that 3x. We're going to do the same thing, minus 2 over square root of 2x squared plus 1. So we're going to reach negative infinity, so therefore I'm going to divide it by this by x. I'm going to divide this by x. I'm going to divide this by x squared. I'm going to divide this x squared. But since we reach negative infinity, that means the result is going to be negative. So you're going to have to put an extra negative sign in the front. So what happened, the result is going to be very similar like this. It's going to be 3 over square root of 2, but it's negative. Okay? So therefore, you have 2 horizontal asymptotes, not only 1. So we're going to look at the graph. Jonathan, can you help me turn off the lights? And Anthony, can you help me type in that equation into there? Yeah, type in the decimals. We're going to type in the 3x minus 2 over square root of this. So, 2x squared. You're going to do parentheses to the 1/2 power. You can do that. Okay, yeah, that's fine. Plus 1.
Actually, right? For that thing, we don't apply the radical to x squared at the bottom.
What'd you say?
Like, you know how it's a radical 2x squared plus 1, and then we divide by x squared?
Yeah.
So we don't apply the radical to the bottom, right? Like, it's not the whole thing?
This still 1 is under a radical.
Yeah, I'm talking about the x squared.
X squared is inside a radical.
No, the one denominator.
This is under a radical, inside a radical.
All of it is?
Yeah, all of them is. Good question. Okay, so now let's look at these questions, right? So let's look at this function. See, do you see the horizontal asymptote? So what we're going to show you is this. We're going to show you 2 horizontal asymptotes. I'm going to type in as a dotted line. So I'm going to say y equal to, it was square root 3 over 2 or 2 over square root 3?
It was 3 over square.
3 over 2 square root of 2, right? And then we're going to do a dotted line like this, right? And then it's y equal to negative 3 over square root of 2. So square root of 2. So, and then we're going to do a dotted line. Now here's a question that, so this is a question that you're probably going to have. How come the function goes through the horizontal asymptote? So, you see this, right? Now let's go look back and look at the definition. The definition of horizontal asymptote is what? When limit x approach to what? Infinity. So it has nothing to do with middle region. because it just says, what if it's like say 100 out here, we're not even reaching infinity, we're gonna say it's 100. So what happened at 100, and are they gonna be plateau into some number? Well, you can see that they're actually not touching each other at this point, but they don't care about what happened in the middle region. So a lot of people get confused that horizontal asymptote, they cannot touch. Horizontal asymptote is a little bit different than vertical asymptote. You can touch in the middle region, but just not the far end, right, and not far left. Because according to definition, it says limit x approaching infinity and limit x approaching negative infinity, but never says limit x approach to 0 or 1 or 2 or 3. It says negative infinity, which is all the way to the left, and positive infinity all the way to the right, so therefore you got a plateau. So if you look at original graph here, you see here, they actually go through it, which kind of doesn't make sense. But not only they go through it, it go back to plateau into negative square root, negative 3 over square root 2. So do you see that there was two things that happened? Does that make sense? So now, so do you know how to deal with radical now? With deal with radical, you just have to divide it by x squared here, and then you divide by x squared here. So it should work for most of the cases. But reaching negative infinity might have other situations. Yes, exactly.
So negative infinity, like all it does is make your final answer negative.
Pretty much that's the one way to remember it. Just you put a negative sign in front, then whatever it does. But sometimes you might get negative and becomes positive.
So
Right?
when it's like a negative number goes.
Yeah, just negative it goes in. Okay, so, but anyway, it's gonna get opposite sign. Any other questions for how to do the homework question at 17 or 18, I think, on the bingo worksheet? So when it reaches negative infinity, now you should be able to do that problem properly, and you should be able to handle that. Now, is those popular question on AP exam? I'm gonna bet my money on it, yes. I'm gonna show you two other questions that is very popular, but this is one of them, when they reach infinity. This is one of the limit question they love to put in there. Are you responsible for that for my test? Yes. And you have to show me all the work. You cannot just say answer is equal to square root 3 over 2. I don't buy that. You have to show me the work, how you get there from there. Can you see, Nicholas? You can see? Nicole, your head's too big. No, I'm just kidding.
No, I'm good. No, you're good. No, you're good.
I'm just kidding. I'm just kidding.
You're on.
Nicole,
I knew.
I'm just kidding. Don't worry. I'm not mean to students.
I can't see your face.
What?
I'm not mean to students.
If you're not mean,
I'm just.
that's a lie.
Yeah,
Yeah.
totally.
Okay, so does this make sense? Now, with the other question, reach infinity, just divide by highest degree on denominator. But sometimes that you might reach infinity. If I reach this result is infinity, do you think we have horizontal asymptote?
No.
Because the graph is going like this, right? So if it's going up, if your result is in positive infinity, then there is no horizontal asymptote. So what you're supposed to write is no horizontal asymptote. When I reach infinity, there's no horizontal asymptote. When I reach negative infinity, there is horizontal asymptote. Does this make sense? Do you know how to do this on the test? And you might see it.
Can you explain the last thing you just said?
I said, sometimes you're gonna have this situation, right? Can you see the screen?
Yeah.
Okay, sometimes you're gonna have this situation that say 3x to the cube and the plus 2x squared over 3x squared plus 4x, something like this. And we say find the horizontal asymptote. Is any horizontal asymptote in this case? Well, the highest power is x squared, so I'm gonna say x to the cube over x squared plus 2x squared over x squared, and then 3x squared over x squared. And then I here it's gonna be 4x over x squared when limit x approaching infinity, right? So I here it's gonna be what? 3x, right? Plus 2 all over 3 plus 0, right? Plus 0, right? So what happens if I reach infinity? I'm gonna have 3 infinity plus 2 divided by 3. My result is more likely to be infinity. If this is infinity, that means do we have horizontal asymptote? No, because the graph is gonna go shoot up like this. How is that horizontal asymptote? So when they reach infinity, that means there is no horizontal asymptote. But your limit is x approaching, its result is infinity. But you're gonna say there is no horizontal asymptote. So that can happen on the test. It says no horizontal asymptote. Yes?
Is infinity a straight line up?
Infinity just go up, just go into infinity. It's like y go to x is going up. It's not straight up, but it's 45 degrees, but it's still going up. But eventually you go to infinity, the x go to infinity, my y value is gonna go to infinity. Does that make sense?
Yeah.
So it's going up, it's not stopping, there's no plateau into something. There is no horizontal asymptote. So in this case, you're gonna say no horizontal asymptote. Any other question? Yes, Zachary?
So why are you dividing the top one by x squared?
Because I take the highest degree on the denominator, I divide it by x squared, x squared, x squared. And I reach infinity and see what happens. But if by this case I have 3x, right? When I reach infinity, it will be 3 infinity plus 2. That 2 is insignificant compared to infinity. It's like you give Bill Gates $2.
Oh,
And Bill Gates is gonna be like,
You gotta appreciate
well, then
yeah. He can probably like just kick it out of your hand and doesn't mean anything to
he
you.
wouldn't do that. So.
Yeah.
Anyway,
Bill Gates nice.
so then why do we do that with that one, but not with the one that's radical?
We do that with that one because we do that with the radical because it's inside here, inside the radical, square root x squared is technically x.
because
No
outside the
horizontal.
radical.
Yeah, but we're gonna divide it inside radical, it's gonna be x squared. So technically, square root x squared is equal to x.
Oh, okay.
Okay, so that's one thing. So now, yes,
But we do if it was x cubed inside the radical.
in x cubed, then you have to, depends, you have to double it, right? So if the inside is x cubed, so you want to divide it by x cubed here, so it's x cubed divided by here, so it'll be 3 over 2. So you had to divide by top and bottom by x through 3 over 2. Good question though. 3 over 2. So now that's a good thing. You're not trying to memorize the questions now. You try to see what if, which is that's lead to a next level of thinking, which is that's good.
Whoa,
Okay.
repeat what happened again?
So she's saying, what if it's an extra third power? If an extra third power, technically, this is going to be 3 over 2 because the root is 2, so it'll be 3 over 2. So you kind of can divide it on the top, it's going to be 3 over 2. Here you can divide by x cubed because inside the x cubed, that's fine. Cube root of x cubed, or square root of x cubed. You have to think about that, or x cubed, so it's going to be 3 over 2, yeah, so if it's 3, you're gonna do divide 3 over 2, so here it's gonna be extra 3 over 2 as well, extra 3 over 2 as well. But outside here is gonna be x to the, which power? No, here you're gonna divide it by x cubed, and here it's gonna be x to 3 over 2, 3 over 2, yes. Okay. So we're gonna show you some range as a question that's on SAT or AP, on AP exam, sorry, I keep on saying SAT. But this question also exists in different formats, and you have to understand different things. So let's talk about these questions. Let's talk about 2 questions. The first question is, can you find horizontal asymptote of e to the x minus 1 over e to the x plus 3? Something like this, so f of x. Now this one you're gonna see it later, but I'm gonna go over it today since we talked about it. But you really need to essentially understand this graph. So again, you're gonna see all the question is gonna be that involved with how does e to the x graph goes? Because that's on my review sheet. It's going like which way? No. How does the e to the x graph go? Do you guys know what's the value of e?
Around 3.
Around 3, yeah. Pretty much pi is around 3 also.
Yeah.
It's 2.7 roughly, okay? So it's 2.7 to the power. So e to the x roughly y equal to 2.7 to the x. Okay? Now just assume that's 3. So we say roughly assume it's 3 to the x. Well, 3 to the 1 power is what? 3. So at 1, you should be roughly at 3, right? At 2, they should be what? 9, right? Okay, how about 3 to the 0 power? 1, good. So you should go like this, right? How about 3 to the negative 1 power? 1 over 3, good. So it'll be roughly right here. And what about 3 to the negative 2 power? 1 over 9, so it's roughly like really, really close, right? So basically it's going to be like this, so close. So y e to the x. So then you have to understand this is a kind of recalling issue. Recalling from here to here, here to here, here to here. You kind of think about it. So what happens when I say limit x approaching infinity in this case? Remember, not all the questions algebraically. So e to the x minus 1 over e to the x, a lot of time it's just analytically or numerically. So what happens if I plug in infinity in this case? Yes. What? Go ahead and say it. Have guts.
Wouldn't it just shoot straight up?
You will shoot straight up. You're exactly right. So this part is going to shoot straight up. So it's pretty much infinity minus 1, right? And now here it's going to be what? Infinity plus 3. Now is 1 and 3 insignificant?
Yeah.
Yes, doesn't matter. But you have 1 exactly 1 infinity over 1 infinity. That's pretty much the answer is 1. Or you can divide it by highest power, which is e to the x. So in this case, I can say e to the x over e to the x. If you want to do that, that's fine. Let's see what happens. So e to the x over e to the x minus 3 over e to the x. What happened when this one? This one's going to reach 1 minus 0, right? Here it's going to be 1 plus 0, right? So that's equal to 1. So therefore, on horizontal asymptote, in this case, to the right side, there is a 1. Am I going too fast? Okay, but how about the left side? Which is kind of scary. Limit x approaching infinity of e to the x minus 1. Now, I'm not going to tell you on this one, so you guys are going to have to figure out what is my answer for this. Negative infinity. But you got to think about it in terms of graph, because a lot of time you're doing a problem you don't think about. You're just trying to do math. Like Courtney is really good at doing math. You want to jump in doing algebra questions, right? You love when something is factorable, you love something that you can work out. But I hear there's not too much thing you can work out because there's not much algebra you can do. So now you have to learn how to think the next level. What is next level? We got algebraically, what else? Analytically, which is thinking about what happened. We're going to talk about that next case. Graphically, good. So what would I graph e to the negative infinity? What do you think e to the negative infinity is?
Isn't that reflected over?
That's what I thought.
Oh, it would be switching between positive and negative, right? Because like when you,
Negative 1.
I hear an answer, but can you tell me what the final answer is going to be? No.
Okay. You can't do it.
Final answer is gonna be.
Thank you. I knew you can come up with the answer. It's negative 1 over 3. Why is negative 1 over 3? And can you explain to everybody else?
Because when you're approaching negative infinity, it's close to 0.
Ah, when the graph, look, what's my output?
Oh.
Eventually go into plateau into 0. So if I reach e to the negative infinity, again, e to the negative infinity minus 1 over e to the negative infinity plus 3, that's saying like 3 to the negative infinity power. That means like 1 over 3 to the positive power. That means 1 over a really, really huge number. That means this part is going to give me 0. So it'll be 0 minus 1 over 0 plus 3. So that's equal to 1 over 3. So that is the answer, 1 over 3. Now this is a higher level AP calculus questions. And this is one question that you're more likely to see when you go into an AP calculus.
Why is it positive 1 over 3?
Negative, you're right. Thank you. Does this make sense?
Yeah.
You cannot just think about algebraic perspective now. You have to think about what happened with a graphic perspective. And I'm going to give you another case and you're going to tell me what the answer is. Okay, can you do that?
Yeah.
Okay.
Wait,
Yes.
do positive infinity first,
I do positive infinity first, yes.
then, so it doesn't exist for regular? Wait.
No, it does. When I reach, I can divide it by highest power, or I can do infinity minus 1, infinity plus 3. So infinity minus 1 is insignificant. Infinity plus 3 is infinity plus 3. 3 is insignificant. So it's actually still $1 from Bill Gates. I'm sorry, Bill Gates, still $1 from you. Bill Gates is like, whatever. Right? So it doesn't matter, it's still infinity. So infinity subtract 1, or you give Bill Gates a $3 tip. So you did good service with your Windows 98. Right? So then we give $3 to Bill Gates. Bill Gates is like, I don't need $3. You know Bill Gates can walk by $100, he can make more money walking by it. That's how much money he make if he just walk past by it.
Not anymore, though.
No, it's not worth for him to bend down to pick up the money. It's called opportunity cost. Okay? So it's not worth for you. Just like some of you guys trying to get a job in high school.
I mean, it is worth it though, because you
No.
get $200.
No, it's not worth it because of the time that he can go
But if
past
he
and do
doesn't
something
stop.
else, gonna make way more money.
Oh,
If he does something productive,
runs.
Well, he always doing something
If he
productive.
runs, then he will make
If
like
he's
driving
doing it
job
here,
at
it's not very
really
productive.
fast.
You think if Bill Gates saw
Yeah, so
$100 on the floor, he would
do
pick it up?
He will not pick it up. He will not bother. Because he will be like, I have other things to do.
No, he might pick it up.
No, his bodyguard made him pick it up. There was a difference.
Jeff Bezos, if he walked out, he has $50.
Huh?
That's a reference to his divorce.
Ooh. Okay, so does that make sense?
Yeah.
Okay, so there are two kinds of situations. I want you to think about this situation. When limit x approach to infinity, or actually we can think about sine x over x. Okay, limit x approach to infinity on this case. Let's think about this case. Remember, this is not the same as before. What's the one that we went over? People always get confused with the other one.
0.
Is approach to 0. That's not what we covered. But approach to 0 is 1, according to the definition. But if x approach infinity, what do you think the answer is? If you can think of it any way, what would you think the answer is?
It's not
Yeah.
just-
What do we do?
Wrong. Good, you're on the right track. Keep on going. Not telling you.
Can you repeat the question?
No.
Okay, what happened when limit x approach infinity with sine x over x?
It's infinite.
Oh, 1, 0.
No. What'd you say? Why you say 0? You had to provide a reason in order to get the right answer.
And it goes by?
Why, Jonathan, why you say 0?
Because just similar to, because if you do graph of sine of x, it's like,
I'm gonna graph sine of x. So sine of x is gonna be like something like this, right? So what is the highest value I can get? 1. So that means it doesn't matter what, it's gonna fluctuate between 1, 0, and -1. But the bottom is what? Infinity. So does it matter if the top is 1 or -1?
No.
It doesn't matter. The bottom goes to infinity, then whole thing become infinity. The whole thing becomes 0. Now I'm going to show you a different way to do it. Let's show you this how to do this algebraically. He did it by intuition, and he said that's 0. That's perfect. And you will get it right on multiple choice.
Which is what the AP exam.
That's what? No. That's not what the AP exam always show you wrong. 54 points on from FRQ. So if this is on FRQ, well, of course it's not going to be this easy. So you're going to say sine of x, the output is going to be fluctuate between what? -1 and what? 1. Okay? Now we're going to use something called, again, what is that theorem again? Squeeze theorem, thank you. It's squeezing between two values. So what I'm going to do is I'm going to make this function look like this one. So what am I supposed to do to all the equation? I'm supposed to divide it by x. Good. See that -1 over x and 1 over x graph? Okay, now, if this one reach infinity, what will happen? Limit x approach infinity of -1 over x is equal to what? 0. So limit x approach to, this one's negative, this one is a positive infinity. No, infinity is going to be 1 over x is what? 0. Therefore, is what? This part has to equal to limit x approach to infinity of sine x over x. That's also equal to 0. So learn how to think. Not learning how to how to do things. So a lot of you guys so used to that algebra stuff, but algebra need to get stronger. No offense, if you still coming to me says you don't know what's cube root of a negative number, it's gonna get unreal. That's not okay. You have to know cube root of negative number is negative. Okay, so those are the things. So let's look at the graphing of this one though. Let me show you the graphing about this one, which is really cool. Hopefully you guys register what I say. I go in pretty fast. So we're gonna graph the sine of x over x here. Okay, do you see that? And this is nothing normal. You're gonna zoom out, you're gonna see there's nothing normal to this graph. So you're gonna say that's the graph. You don't see nothing special, right? No, right?
Yeah.
So we're gonna show you what is something special. Let's graph that squeeze theorem from the other side. So it'll be negative 1 over x and 1 over x. Now do you see this?
It's gonna be like, you'll never technically.
Do you see that?
Yeah.
I'm squeezing between the blue line and the green line. And it will keep on going and acting like an asymptote of 1 over x, but except you can touch this point. So eventually that if the green line and blue line they go into 0, therefore the red line is going to 0. It's kind of squeeze a function inside. I teach a little bit different than last year. Last year I was so focused on the mechanical part. But this year I really want you to understand not only the mechanical part is important, but it's also the thinking part is important. Because the thinking part is what is going to get you a 5. So right now the people who has a brain to think that 5 are just Matthew and Jonathan right now. But I need way more than 2 students. You guys are going to have to come up. Suhani come up. Anthony need to come up. Other people need to come up. Now Rihanna may be next. Anna may be next. We're here may be next.
Who?
Okay?
Rai.
Right. Sorry about your name. I'm not good at pronouncing people's names. So yes, so not only one person. I don't want to just train for you guys to pass. I don't think that's good enough. Mechanical part, you guys have to improve to get order to get 3. But you guys also have to have the creativity part to get to the 5, which is thinking about different things on different aspects. Your test gonna have a question that you're gonna have to think outside the box. Whatever is in the box is not enough. Whatever you're doing mathematically is not good enough. So you have to think about how you're gonna get there. 4 different perspectives. Always keep in mind, graphically, algebraically is 2 essential ones. Analytically and numerically, sometimes it's gonna help you get there. A lot of time it will help you get there. So you have to think about all those things. So I will say percentage of the things is 60% algebraically and 30% is going to be graphically. And then you have the rest of 5% and 10% are rely on analytically. So, but you can get those every single point that you can think of. Okay? Also, you guys didn't ask me a question about a IBF.
What?
Good afternoon, students. A couple of quick announcements. First, looking for some students who want to improve the school environment, one that can rely on social norms to change the power of students.
So remember this question I can ask you.
Information is on Wednesday, September 11th after school in the state office, in the front office. See you on Wednesday.
Okay, there's a close boundary, right?
Be the first and second.
I don't know if you the answer is homework question. And we say MC is equal to, I say, I don't know, 10. So it's any value IBF can put this. So what are you supposed to do?
Your painting must be in good taste.
Plug
Plug in -2, right? And plug in 5, right? And see if they go through 10. But in this case, you actually did it wrong.
Next, the Black Leaders of Tomorrow are holding an interest meeting on Monday, September 16th, in room 7204 MT30. There's a fun-packed year
What?
ahead of
What'd you say?
It's 1 over x
service
and
pass
9.
opportunities and
Yes.
college preparation.
No, I thought you were on the right track.
Great opportunity.
No, it's nothing to do with bracket.
Everyone is encouraged.
That you were here again?
Make sure you purchase homecoming tickets now on school pay for $40. Check
What do you mean not
on
possible?
launchpad to make sure applications are cleared as they
What?
must be. It would dead. Pick up when you're coming out of school, get the application outside.
You never know.
On
It's
the
possible.
SGA bulletin board.
1 over negative.
Are you interested in being on the 2019?
And actually, you're gonna get a value.
You must attend
That
the
is equal to
information
that.
meeting of
So
September
C is gonna
19th,
be-
5107.
C is gonna be something.
Again, check that SGA bulletin board for more information.
Actually, C is I can figure out
Finally,
a
the
C.
end for
It's
dual
1.1.
enrollment, with Ms. Dye is today, so make sure if you're interested in next year's.
Because what?
enrollment, you see
1
Ms. Dye
over 1.1 minus 1.
And finally, the history of the
Yes.
first interest
See,
on this
that's
year-
what he's thinking.
Of this year on Thursday.
At x equal to 1, there's an asymptote. It occurs in the -2 to 5. There is a discontinuity at 1.
And with that.
Therefore, intermediate theorem does not apply. It might have this value, but intermediate value theorem is not the reason. Okay, those are the stronger questions for you guys to think about. Good job, Matthew. A lot of you guys need to start thinking those stuff. Look at the condition. What's the first condition? The function has to be continuous. Is the function continuous at 1? No. Therefore, between -2 and 5 does not guarantee that it's going to have this. You can possibly have this, but it's not due to intermediate value theorem. It's due to something else. It's not due to intermediate value theorem. That does not prove to you. Okay? So that's it. Whatever. Good job. To think about it, all those things. Test Thursday. Or tomorrow, new stuff. Make sure you go back to understand the